This is another good time to meet you, and I'd like to take this opportunity to honor and respect you and to greet you for these good moments of learning and pushing ahead about our responsibility, about our business. My name is Olenjolain. It's the first time to meet me. I thank God by His own grace. I'm going to lecture you, and actually I'm going to make sure to equip you with the technical skills about electronics communication laboratory. So in this course, we are going to have a discussion about details, informations, or the working principle of one of the encoder. I think that the principle, yes, so the title has to change a little bit. So this one is called the working principle. So the working principle. So workshop 6 is called the working principle. Working principle. Working principle of Ht12E encoder. Encoder, I see. So working principle of Ht12E encoder integrated circuit. So it's very interesting concept because we are heading to the practical, and for this part, we won't discuss about its simulations. Once we cover the theoretical concept, which is actual help us to do the practical, then we'll dive directly into the practical or hardware implementation. So I would like to ask you students to concentrate and keep on. How are you, students? Get in. How are you? How are you again? Eh? How are you, students? So until you have been asked this several times. Matatu? Matatu? Sit there. So let us start with a quick review of what we've covered in previous workshop. So quick review of previous workshop, and this was workshop 40, workshop 5. So in workshop 5, actual, we covered about 30 definition. In case you have a question, you may ask it. Definition of encoder. And then we say that encoder, actually, that it takes the binary input, and once it takes that binary input itself, it encodes that binary inputs to give out the coded binary output. So we discussed about the two definitions, but then I told you the formula that you are using for the encoder, which is 2n, and then 2n. And then after that, we discussed about some examples of encoder. And some of these examples of encoder, we had the 2 to 1 encoder. Also, you have 4 to 2 encoder. Also, you had 8 to 3 encoder. But also, he said that he can have 80 but to 1 encoder. So those are the examples, and this is the general formula. Again, another concept that we have learned after we discussed about that. Then we say that every encoder or encoder, all the encoders that you have in digital electronics, encoders and the decoders. So encoders and decoders, we say that these are made in terms of 40 pair. So they are made in terms of pair. So for instance, HT, because we discussed later on, so we discussed about Ht12E encoder, then it has its own pair decoder. So it means that this one, it's made in pair. So there's another pair of 40 of decoder of the same family. Then again, we discussed about this Ht12 encoder. What does it mean? So we discussed what the meanings of Ht12 encoder. And then we say this encoder has 4 input data pins, and also it has 12 address pins, and there's only single output pin. So that's how we define the information, defines about Ht12 encoder. It's a very important encoder that we are using in communication engineering. But again, we had what? Again, we had a very important concept, or we discussed about another important concept concerning about encoders, and yes, especially about encoders. And that important concept, after we discussed about that, we discussed about the physical appearance of 40 of Ht12E encoder IC. And itself, we say that it has actual 2 packages. The first one is 18 dual inline packaging, and the other one is 20 SOP, not SOP, SOP packaging. So we discussed about these 18 pins. And in these 18 pins, there are deep integrated circuits of what Ht12E integrated circuit. We realize that we have through-hole and surface mounting device. But also, we realize that we have we learned about the pin number and the pin names of this integrated circuit as a through-holes integrated circuit. Then I left the homework to all the students, online and physical students. And the homework is actually explain briefly how does Ht12E encoder integrated circuits work to encode the binary input data. That's the homework that I left it to you. So, and that homework, it's the heart of today's workshop. So, where that we are going to learn about working principle or principle of Ht12E encoder integrated circuit. So that's the point that we are going to discuss right now. We discussed about features also, right? Eh? We discussed about features, discussed about pin name, discussed about pin number, and that concept was exactly, was real. Yes, was real clear, or was well taught and understood. So working principle, say working principle. Say working principle. Again, say it loudly. Say working principle. Say working principle. Ah, today you are in strike, eh? And that strike is led by Benjamin Joseph. So working principle of Ht12E encoder integrated circuit. So the primary function of Ht12E encoder integrated circuit, Ht12 encoder integrated circuit, integrated circuit, is to encode. So to encode a 12 bits. When you talk about 12 bits, we mean that four data bits and the 4 address bits. We mean that 4 data bits and also 8 address bits. 8 address bit, and send it out through the output pin. And send it out through the output pin. So this is the primary. So the primary function is just to encode. Say to encode. Say to encode. So to encode what? To encode a 12-bit binary input. So a 12-bit binary input. To encode the 12-bit binary inputs and send the outputs through the output pin. So each data or address input pin. Each data or address input pin can be set to one of the 2 logic states. Can be set to the one of the 2 logic states. So each address or data pin, input pin, so remember that address pins are defined as the input pins, but they will not receive the input from what? From the digital source, but they will supply the input to the information signal that required to be encoded and be given an address. Are we together? Let me repeat. We have only, or we can supply the inputs, stop writing. We can actually supply the input digital signal to the Ht12E encoder through the 4 data pins. But also in that integrated circuit, we have 80 address pins. These 80 address pins are also defined as the input pin, but the user of this integrated circuit does not have access to supply any address to it. But what happens? These address pins also will add the input, or will be defined as input, because they will add an address to the information which it will be encoded by Ht12E encoder. Is it clear? What did you understand? Where is the exercise book? Dominic, yeah? Where is the exercise book? Sorry. So either address input pin or data input pin can be set to one of the two logic states. So it means that address pin can be 0, address pin can be 1. Data pin can be 0, data pin can be 1. So it depends on your configuration and depends on your intention. Are we together? Again, we say that these integrated circuits you find sometimes, because in case of the programming, we have programmable integrated circuits and also we have non-programmable integrated circuits. It means we have some integrated circuits which have built-in program which have been only or which have been built within by the manufacturer. You yourself as a user, you cannot add your own code or you cannot upload codes to those non-programmable because in case we have non-programmable integrated circuits and also you have programmable. So programmable integrated circuits means the user is the one that has been given an access to write the code according to the function or the functionality or according to the desire, the strong desire that you want that integrated circuits to perform. But also in case of non-integrated circuits, we have two types. We have non-programmable, and in case of non-programmable integrated circuits, we have two types. We have non-programmable integrated circuits which does not have any program, for instance, 5-5 timer. And also we have some fixed non-programmable integrated circuits. So some of the integrated circuits, they have a program which is actual, we call it, there's a language that to program digital integrated circuits that we call it VLOG. So we say that they program the address address, they program the address or data are transmitted together with getting nation. You are nation who? Getting. This is in Feeling. Do you know Feeling? Make sure that yesterday, both nation, you and you were not in the class. Today, you are in the class, but you came first before this man. So I would like to ask you, nation, to make sure this man is in the class for all the remaining incoming classes. So once you arrive, you check the second nation, okay? And use the message format to communicate with you. So actually, we say that these data pins or this data information will be added something called the header bits, and then transmitted via the RF or the infrared. The RF or infrared transmission medium. Transmission medium. Okay, transmission medium upon reception of the trigger signal. Upon reception of the trigger signal. Of the trigger signal. So you say that, so the programmed address or data are transmitted together with the header bits through the RF or radio frequency transmission medium and the infrared transmission medium upon receptions of the trigger signal from the transmission enable pin. That's very important. So we say that programmed, we don't mean that you are going to write a program. No. it has a fixed program within it. So the Ht12E provides the capability to select a transmission enable pin, which is actual TE on the HT transmission enable pin, which is TE on the Ht12E encoder. Further enhances the application of the 2/12 series encoder. Then before we learn about how we can construct the schematic circuit diagram of Ht12, constructing the schematic circuit diagrams that will encode the information. Before we discuss about that, let us discuss about some common applications of Ht12E encoder integrated circuit. Why do we need it and why do we have it? So these are the descriptions of what is going on or what it can do. So the following are the applications of Ht12 encoder IC in real life. So number one, so you say that this one is used for burglar alarm system. The second application, we use Ht12E encoder just in designing of what it is used to design the smoke or fire wireless alarm system. Used to design the smoke, fire, wireless alarm system. But also this one is used to design door controller system. So in case you want to design the door controller system, this encoder is important to encode the information. But also this one is used to design the car alarm system. So when you say burglar alarm system, it means a domestic alarm system. The car is used to design the car alarm system. But also this one's used to design the car door alarm system. This is the car alarm system. You know that some cars, in case that you touch them or you approach, you touch them, they can sense and they produce an alarm to alert that somebody is on your car. But also we use this Ht12E encoder to design the security system. Security system. But again, we use it is used to design the cordless telephone. Cordless telephone. Go out. Cordless telephone. This one is used in other shorty remote system. So those are the 8 applications of Ht12E encoder in real life situation. That's why that you have to learn and cover. Again, you are late. So today I will punish all of you because you are always late comers. Huh? Always late comers, so you are expert. So, stop writing. Let us read the first application. 1, 2, 3, let us go. You know how you let me down. You are more than 50 in this class. It is usually. I say stop writing. I say stop writing. Let us read the first application. Say 1, 2, 3. This means home alarm system or domestic alarm system. The second one. Rollins yourself, read it. Rollins. I don't hear you. I don't hear you. Speak loudly. Matatu, read it. Matatu. Read it, Matatu. Yes, read it. Even myself, I have coughing. It is easy to reserve. To design. I had to design what? Small fire. Okay. So it is used to design the smoke fire wireless alarm system. We know that some buildings, they have alarm, just a fire detection system or smoke detection system. So one of the components that might be used in designing that fire detection system or smoke detection system is this one, Ht12E encoder, to encode the information to differentiate the information which have been sent in air so that the decoder can receive, or the RF receiver can receive the information, the decoder can decode. Then the third use is used to do what? To design what? The door controller. Say door controllers. In your expectation, you say that when you build your own house, you'll have electronics throughout your own house. Isn't it? You'll have automated system and you'll build yourself. That's one of the ambitions you have. But I'm not sure that if it will be practical or it will be just a dream. Because first of all, owning the house nowadays is not easy. Mostly contemporary houses, if you talk with civil engineers, they could take mostly, the cheap contemporary house is almost 30 million. That's the cheapest. But hopefully, you can find 60,000 million. So 30,000 million and 60,000 million. Millions still. So now, you know that yourself, what's your expectation and how much is surrounding your hands. Okay, then the first applications we say that is used to design the car alarm system. Say car alarm system. There are some cars, especially these modern cars, in case that you approach to the area of vicinity or you touch it, then actually produce what? An alarm. Or sometimes, and that alarm when it's producing Gaudes. Ha! Yeah. That is heavy dose. Gaudes, go out, go out, go out. Okay, so you can hear an alarm, and at the same time, when you hear the alarms nearby the car, also the driver key produce an alarm at the same time, but depending to the distance. So for instance, if you park your car at DAT, and when maybe you are doing your private studies, if somebody approaches your car, you will get a notification that somebody is touching your car by hearing the alarms on your key. Okay? So Ht12E encoder might be used for that purpose. And then we have the fifth application. This one is used to design what? The car door alarm system. Say the car door alarm system. So some of the modern cars, in case that the driver wants to to inject the gear and to start moving, but he or she has forgotten to close the door, an alarm will be given out. I think you have seen them, right? Have you ever seen them? If you haven't seen, even in the movie, ask your neighbor, even in the movie, because maybe you haven't seen it physically. In movie, because your neighbor has intensive movies. How many movies have you ever watched this since your first year? 20? Number 6. This one is used to design security system. Say security system. Yes, in 2020, yes, 2019, 2020, I used this encoder to design a security system, which was actual that the car security system in garage. Say garage. Say garage. Yes, so it means that it happens, it has been observed that in most cases or in most scenarios of thief, nowadays the car, what it means that those intelligent thieves, they don't steal the whole car. They just need the expensive parts within the car and then leave the board for you. So what the existing system right now, you can use dogs, but dogs also can be tricky, right? What another existing system, you can use CCTV, but CCTV will actually show you how the parts of your car have been taken. But it does not give you any notification, and also it does not tell you where the parts have been taken. You just go and check the footage, and once you see the footage, you see, this is how they, okay, this is how they took something, this part, yes. So my system actually was was producing the notification to the owner of the car. I had a transmitter, which I had used the 4 sensors, and those will be in the garage. When you say garage, we means that garage, the home garage, where or the parking place, the home parking place, right? Right? So I had my transmitter unit, which had 4 sensors within the or surrounding the area where the car is, in order to make sure that to detect the signal in 90 degrees. So 90 degrees, if you have 4 sensors, 90 times or 90 degrees times 4, we get 360 degrees. So you have a total coverage of your garage. And then once any intruder is detected, especially the human being, then the system will send a signal to the receiver, which is in the car owner's bedroom. So you'll hear the buzzer. That is the first version. The second version that I was heading about, but I was still heading to it, then we wanted to integrate with what we call it certain kinds of the water that used by policemen, especially in case there is a strike. We call it in Swahili, maji ya washa washa. So it means that while the diff is actual, it will not actually that see, because the lamp, there's actually, we call it a high power lamp that will be there, which will be turned on when there's an intruder. Okay? That's one of the notification to the intruder that you have been detected. And then secondly, what we are planning, one of the boss that just gave me that idea, he was saying that if the laws give us permission to integrate the transmitter with a gun, that could be could be what? Okay. So once the thief is detected, then the gun and that thief is Johannes Bandito. We'll miss him real. This isn't? But Johannes Bandito is a very good civilian man. Yeah. So he said, yeah. So I used this encoder. I used this encoder in different cases. I used it to design robot. I used to design security system. So I used this. So I've been using this Ht12 encoder since 2018. So almost I've been using it for 4 to 5 years consecutively. So I know how does it work and how effective it is. And when I design a system, it can work the entire year, 365 days, and the encoder still persisting the situation. Are we together? Are we together? Okay. Then the other, number 7, is used to design cordless telephone. Say cordless telephone. You have telecommunication practice. You have a module called the communication system. I think you have learned a lot about telephone, right? But you have some telephone, we call them cordless telephone. So cordless telephones, it means that sometimes you can just have a handle, but the receiver is a little bit distant. So it's a cordless telephones, it's a telephone, but it's wireless. So while you have a handle, you can use a handle and move, but the receiver that receives maybe the voice signal from the other parts or from the microphone is a little bit far from there, because simply this encoder we use them in the short distance communication systems. That's all. Okay? Are we together? Then this one is used in OT, other short remote OT system. But number 9, this one, this sensor, it is used this encoder is used in design of robot. We call it robot, yes, robot. So then, that's all about what, those are some of the functions. Now, let us dive into the important part. So Edson went out to meet his friend. Okay, latecomers, get in. You don't know how to say thank you, go back. And then learn the chorus of thank you, sir, thank you, sir. Once you master, let me know. How can you use the Ht12E encoder integrated circuits to design the short distance wireless transmitter. Are you ready? Eh? Are you ready, latecomers? Okay, practice there. I want to hear your chorus. I said I want to hear your chorus with your colleagues, not yourself. So establish the chorus. I want to hear the high range, the low range. So then, let us think a little bit, how can you use this encoder to encode the information in the short distance wireless communication system? You said you're a civilian. You know meanings of civilian? What does it mean in Swahili? Huh? Usalama? Ustaarabu. Wewe ni mtu mstaarabu. Lakini mtu mstaarabu mwalimu anakuambia acha kuandika unafanya? So these are the steps. So you say that how can you use the Ht12E encoder IC to design encoder to design the short distance wireless transmitter. The short distance wireless RF transmitter. So the first steps, so we say that follow the following steps. So the first step, we say that connect the DC power supply to the 18-pin, what you call the VDD. So the first step, we say that connect DC power supply Have you finished this part? I want to clean it. Have you finished or not yet? Eh? Not yet. So connect is already to say connect the DC power supply to the 18 pins, which is called the VDD. I say read it. Eh? Okay, this side, you yourself, read that first step. 1, 2, 3. Zuena Masebo, yourself? She's not there. And this side, 1, 2, 3, read it. The second step, we say that connecting the common ground of the power supply unit to the ninth pin, which you call the VSS. The third step. 1, 2, 3, let us read, all of us. The second step, read it. Bundala, read yourself and read it loudly. The component. Read it loudly. And the whole class, read this. I'm really asking you to pronounce these steps because they have to be written in your subconscious mind. These are the important steps that we are learning in the class, but later on we are going to apply in hardware implementation. So these are the very important information you have to write in your mind, because whenever you do this, all of these digital ICs, especially encoder and decoder, they are very sensitive with power. Once you do a single mistake within a fraction of a second, then you'll find that you are talking another story. So let us read the second step. 1, 2, 3, let us go. Sonia, come. I told you don't sit there. Come with your stuff. So we are reading while Sonia is slumbering. Again, read it loudly. Connect your T, common ground. Say common ground. Say common ground. Eh? Connect your T, common grounds of the power supply unit to the OT, to the 9 OT, 9 pins, which we call T in other words. So we use to call T. The pin name is called OT, VSS, voltage across OT, source. That is the third step. That's the second step. The third step, we say that connecting the first 5 address pins, we mean that A0 to A4 to the DC power supply. DC power supply, which means that connect them together with the VDD. So the first 5, say first 5. So let us read this, say this tape. Stop writing. 1, 2, 3, let us go. Get through yourself, read it. We are waiting you get through. Hurry up, please. We don't hear you. We don't hear you, please. So let us read for Gertrude, because Gertrude was a little bit out of the class. 1, 2, 3, read it, the steady state. So I will mention the steps, and then you draw this schematic circuit yourself, because you are not paying attention on what we are discussing. So at this time, we are just to say connect, but you will connect yourself. Dennis? Move. You are disturbing Dixon. The first step, we say that connecting the 4 remaining address pins to the common ground, or the common ground of the DC power supply. So connecting the 4 remaining address pins to the common grounds of the DC power supply. Ready? T? So connecting is a 1 or 2 or 3 or 4 binary data inputs. To the 88 or 89 or 8010 or 8011. Read the 50 step. That is not a 1, 2, 3, 4. No. 1 or 2 or 3 or 4. So read it again. Ah, 11. So others, they are waiting just to say 11. Is it clear that it's a 50 step? Why is not it clear? Refer what you have covered yesterday. This is just adding the value of what you have learned yesterday. You had the physical appearance of Ht12E encoder. Hurry up! So did you understand the first step? Eh? Did you understand the first step? Yes. The second step? Eh? The second step? Did you understand the second step? Connected the first 5 address pins. You don't know address pins that found in a Ht12E encoder? You don't know. Eh? So inside the first 5 address pins, it means pin number what up to pin number what? Pin number 0. A0 up to, no, I've written there A0 up to A4. A0, it's a pin name. It's not a pin number. Tell me the number. Eh? Pin number what? Number 1. Up to pin number 5. Very good. And hence the first step, connect the 4 remaining address pins to the common grounds of the DC power supply. So give me the number of those 4 remaining address pins. Connect. Yes, give me the pin number. Nation. Go out to dress yourself. I'm nearby you, but you're still making the business. What the number of those 4 remaining?
There is confusion there.
Confusion. Which kind of confusion?
You said we have 80 address pins.
Yes.
And now you said connect 5, and the next 4.
Ah, thank you. Okay, thank you. These are 3. Why didn't you ask it before? Class A, number 7, number 8. AKA, we can call them that this is A what? So in case of A, remember that there is a lagging behind because we start from A0 to A5. So here it means you say that this is A0. Where do we have address pins, Yes, A0 to A4. So this one is A5 to A7. In terms of what? Pin name. In terms of pin number 60, pin number 7, pin number 8. Jacqueline, go out. Then we say connect either 1 or 2 or 3 or 4 binary data inputs to the AD8 or AD9, or it means that, what does it mean? To the AD8 itself, or AD8 and AD9 for the 2 inputs, or AD8, AD9, AD10 for the 3 inputs, or AD8, AD9, AD10, AD11 for the 4 inputs. But also it is possible. You just have 2 inputs, you can connect it. 1 input at AD10 and AD11, or AD10 and AD8, or AD8 and AD10, or AD8 or AD11. So whenever that you have a less than 4 data inputs, you may use either or any among the 4 input pins. So you should not claim that I should use AD8, no. But once you use that AD8, you have to remember in case of its decoder, because in case of its decoder, also once you use the AD8 there, you have also to use the AD80 in case of the output or for the part of the decoder. We are going to discuss it later on. So this step is actually talking about the input. So it depends that you want to use this encoder to encode how many bits. If you just want it to encode 4 bits, then it's fine. You use all the 4 data pins or data input pins. If you want to use just to encode 3 bits, then we'll be just using 3 of them. Then the next is step number 60. Step number 60. We say that we have the next pin, which is pin number what? 10, 11, 12, 13, pin number 14. Then we say that pull up the transmission, so pull up the transmission enable pin, which is actually means that pin number or pin 14, pull up the transmission enable pin to the ground. Pull up the transmission pin or transmission enable pin, which pin 14, to the common ground. What does it mean? It means simply connecting the pin number what? 14 towards what? Towards the ground. Carolina, where is Nora today? Nora was not present. Nora was present yesterday. Where is Nora? She's studying digital. Where is Anastasia? Anastasia, yes, she's around. But Nora is missing in your group because you are kindly friends right now. And yesterday I found you somewhere, enjoying the evening. In W15-1, W15-2. So 1, 2, 3, read this 60 step. Eh? Pull up. Is it a pull up resistor? 1, 2, 3, read it. Pull up what? A. I say 1, 2, 3, read it. Do you have common ground? Ask your neighbor, do you have a common ground? You don't have, eh? The seventh step. The Ht12E encoder. Kevin Mageni, clean the blackboard. Encoder, I see, has built-in oscillator. That require the, are you writing? No. Why? Because you forgot your exercise book. When are you going to write? Do you think that you'll have time to write? You write. So for this case of data pins, for our case, what are we going to use as the data input or to supply the input to our Ht12E encoder IC? What are we going to use? What did we learn in previous workshop that we are going to use as the input for that system? Who can tell us? Who can remind us? Because I've already taught you about what we are going to use there. Who can tell us, Amedeo? Tell us. What are we going to use there as the binary input? Quickly, Amedeo. It's very simple. I taught you in this same class. I taught you. And just still in July. Today it is 10th July. Just remember what I've taught you between 1st and the 10th July. Not even last June, last year, May, or last April. So what are you going to use? No idea. Shadrach? I didn't ask you that no idea or no there is idea. Why did you rush directly at no idea? Boniface, because you have been laughing. Boniface? What are you going to use there? Ringo? No idea. Wonderful. Vanessa Robert? What are you going to use there? Are the inputs? Either 1 input or 2 input or 3 inputs or 4 inputs. What are you going to use? What did you learn in advance? No idea. Mabeza? Can I ask this one to help you? Dominic, what are you going to use there at the input? Ruben? So the Ht12E encoder IC has built-in oscillator that require the external resistor of resistance of this one external resistor of 680 of resistance of 680 kilo ohm. $680 kilo ohm. So without that resistor, with resistance of 680 kilo ohm, that built-in oscillator will not oscillate to, actually that will not oscillate to help the encoder to encode the information. And these values, all of these values, or all of these steps that you have to follow according to manufacturer's mind. Some of them are according to the manufacturer's mind, but some of them according to intensive use of this encoder in telecommunication engineering. So we have discussed about oscillator, then the next step, the next pin. Which pin did you not discuss? So for the oscillator pin, we mean that oscillator what? Oscillator number 1 and the oscillator number 2. So this represents pin number what? A, oscillator pins. Wind feeder, wind feeder, wind feeder, wind feeder. Oscillator pin, pin number? A, number 10. 15 and what? Are you sure? Huh? No, she's not sure. Halimi? Huh? You are not sure with what? Show me. Show me first the diagram of the IC. So oscillator number 1 and oscillator number 2. Pin number what? You wrote yourself, but you cannot read. Pin number what? Latifa? Are you sure? Ask Neema. Is she sure? So this is pin number what? A, 15 and what? 16. So how many pins remain that we did not discuss? A, 1. That is called what? D out. This is Shukuru's exercise book. Do you see Shukuru's exercise book? So this is Shukuru's exercise book. Actually, he has stolen it from Dennis. Then number 8, we say that connect the out pin to the connect the D out pin to the data pin of, in most cases we use this one, 400 megahertz RF, 400 megahertz RF, 400 megahertz RF transmitter module, RF transmitter module. So connect D out, and remember that D out is pin number what, Carolina? D out is pin number what? Carolina, D out is pin number what? 17. Very good. But you left in Nura. So D out is pin number 17 to the data pins of the 400. Say 433 megahertz RF transmitter module. Say it, Johan. Say it, all of the students. Megahertz. 433 megahertz. Again, say it. A RF transmitter, you will use it. Transmitter module. So connect that once. And then step number 9, we say that cross-check. Say cross-check. Cross-check all the connection. Cross-check all the connections before you turn on the DC power supply unit. So you have to cross-check all the connections. Say all the connections. And this is the principle of designing or implementing an electronic circuit. Before you turn on power, you have to cross-check. And in most cases, in your cross-checking, you have to use the continuity tester or the continuity check. But also you can do you can perform the visual inspection. Why? Because in case there is a short circuit, when you turn on the DC power supply, you are going to damage some of the electronic component. So it's better for you to cross-check several times, not only one time. Cross-check it several times. And sometimes, if you cross-check and you see it is fine, you can give your friends just to cross-check also for you. Cross-checking all the connection several times. Several times. Before what? So turning on the power supply will be the last step after you are sure about your connection. Are we together? Are we together? Class, are we together? Remember that for this part, connecting either 1 or 2 or 3 or 4 binary data inputs. We may either get these binary data inputs by having a digital sensor, or we can have analog sensor, but between the encoder and the sensor, the analog sensor, we need to have analog to digital converter to convey the analog signal into digital signal before we apply to the inputs or data pins of 40 of the Ht12E encoder. But if you have a digital signal, that's fine. You can connect the sensor directly to the Ht12 encoder. Also, we may get those binary bits, input bits, either 1 or 2 or 3 or 4 by using pull-up resistor network or pull-down resistor network. You may use 1 pull-up resistor network or 2 pull-up resistor network or 3 pull-up resistor network or 4 pull-up resistor network. You may use even sometimes 1 pull-up, 2 pull-up resistor network and the 2 pull-down resistor network. That's fine. It depends on your design. So from this moment onwards, it means that you have different styles, or you can use this Ht12E encoder in different design according to your requirements. Are we together? If now you'll be integrating this encoder with microcontroller, I want to tell you that, my dear students, you'll be designing very interesting system. And I have a plan to teach some of you who will be interested at that level because for instance, for my project that I have done it and I want to redo it again because I've dismantled everything. I use the microcontroller and 2 microcontrollers for the transmitter part and also for the receiver part. When now you integrate with the power of the microcontroller, I want to tell you that you can design a very intelligent system and it's a wireless system. Are we together? Eh? Okay. So if you are together, stop it. Okay, so right now, let us follow those 80 steps or 9 steps. But when you are following those 9 steps, we have also to make sure that we follow the previous steps that we have to follow we have to use the general block diagrams of Ht12E encoder with different peripherals. So right now, we can draw overall schematic circuit diagram, overall schematic circuit diagram of Ht12E encoder. So we say that we have to start from the DC battery. This DC battery that we are going to use will provide 9 volts theoretically. And then we need to have a voltage regulator. The good thing that this IC and all other peripherals, they just need only 5 volts for them to operate. Then at this point, we have ceramic capacitor. So ceramic capacitor. At this point, we have what? Ground. We have ground. At this point, we have also another ceramic capacitor. This is 0.333 microfarad, and this 0.1 microfarad. So you have also common ground. So at this point, we say that we need the T-block connector, which may have maybe different pins for the hardware implementation. Then at this point, we can connect all of these grounds. So you can connect all of these grounds in one of the connector. So at this one, we have this one, we have this, we have this. So this is for the practical purpose. For the just theoretical purpose, we don't have these 3 blocks. These 3 blocks are not the part of the circuit. So this is actually DC power source. Then we need to have power indicator. Need to have power indicator. But you have to remember that we need also testing points. So you need to know the voltage across. This is testing point A. And then at this point, we are going to have another testing point B. At this testing point, we'll be measuring current and also we'll be measuring voltage. So we'll have the C voltmeter. Then this is the resistor. Here you have resistance. We can use just the 200 ohm just to indicate the power. At this point, we have a power indicator, which is LED. Then you have ground at this point. So it can be ready LED. So this is just implementations of DC power supply. So you have testing point A, testing point B. Yes, those are the two important testing points. We are not interested to know the voltage across resistor and voltage across the LEDs. Class, are we together? Then we think about the inputs. So for the inputs, because when you draw the physical appearance of our Ht12E encoder, once we draw it, we find the input data pins lies on the left-hand side. I say that if we draw the physical appearance of Ht12E encoder, then you find the input pins are located on the right-hand side, not on the left-hand side. So maybe to simplify the concept, it's better for you actually that to draw your pull-down resistor network. Your pull-down resistor network. Sorry. So for this case, yes, you have grounds, that's fine. So you can draw your pull-up resistor network at this point. So you're going to have what you have push button. Then you have resistor. And this is 10K, 10 kilo ohm. So this is push button 1. Again, you may have another. So R1, R2, 10 kilo ohm, common ground. Push button or button 2. This is button 1. So this will be our two inputs. Then we need to have our control unit. This is Ht12E encoder. But remember that here we have another testing point we call testing point C. What are we going to measure? This testing point, voltage, V across R1. So this will be the input voltage to the encoder. Also this one, it's VR2. So VR2, and this one testing point D for the input. So how many pins does this IC have? Class, how many pins? 9. 83. How many pins does it have? Kankesha? Kankesha, how many pins does this IC have? 1, 2, 3, 4, 5, 6, 7. 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the 9 pins. 9 plus 9. So now you change the language. So pin number 1, pin number 2, pin number 3, pin number 4, pin number 5, pin number 6, pin number 7, pin number 8, pin number 9, pin number 10, pin number 11, 12, 13, 14, 15, 16, 17, 18. The pin names, this is A what? A4, A0, A1, A2, uh-huh, 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 uh-huh. And this one is what? VSS. Ah. So you have a pin called the VSS. Wonderful. This is AD 9, uh-huh. AD 10. Mm-hmm. AD what? TA, transmission enable pin. This one is what? It's letter 2, it's letter 1, the out, VDD. So you can draw this schematic circuit from your brain if you have understood what you've been discussing in workshop 4, workshop 5, and workshop 6. There's no need for you to refine, check the exercise book and open, and just troubling. You just need to understand. So first of all, we have to, the first step, now let us go to the steps, open the steps. Open the steps, because those are the steps for design. The first step is what? So DC power supply to the what? 18 pins. Where is that DC power supply? You just take a jumper and connect it with pin number 18. You have finished the first step. Because I know some students say that, you know that. Me, I like doing. I don't like weights. You cannot do without weights. Okay, then the second step. I say read the second step because you have to follow those steps. So where is common ground? This is common what, class? Common what? Common ground. So we take one jumper and connect it to the ground. Ground is called the VSS. VSS is the abbreviation of what? Voltage across source. Kankesha, you told me that you understood workshop 5 a lot. But now what happened? Something happened there. The devil has. Then they had the third step, Kankesha. Kankesha is far from the class. Connect the first 5 address pin. So pin number what up to pin number what you call this the first 5 address pin? Pin number what? Number 1 out to number 4. Number 1 up to number 5. Or A0 up to A4. That is simple. So this is the first pin, second pin, third pin, fourth pin, fifth pin. So what you have to do, you have to interconnect. So you are going to use jumpers. Students, when I be drawing, it's very simple, but to build it is something else. And I told you that when I'm teaching you, I will never be with you. You will build yourself. I will come to assess you. So, pin number 1 and pin number 2 are interconnected by using a jumper, a male-to-male jumper. Pin number 2 and pin number 3 are interconnected by using a male-to-male jumper. Pin number 3 and pin number 4 are interconnected by using the male-to-male jumper. Pin number 4 is connected to pin number 5 by using male-to-male jumper. Seni, we have finished to interconnect the first 5 pins. But these first 5 pins, we have to connect them to the what? DC power supply. Are we together? Are we together? Omachi? Good. Then read the first step. Digna, no, not everybody. Digna, read the first step. Connect the 3 remain address pins to the OT, the common ground. What are the names of those 3 remaining address pins? A, A3, IMA. The names of the 3 remaining pins. Not numbers, names. You have registration name and you have a name. Your name is Emmanuel Elias. I ask you your name, the names for those pins, not the number. What are the names of those 3 remaining pins? A? What? A? Speak loudly. Why don't you trust yourself? A5, A6, and what? A7. What are the pin numbers? Pin number 10. Number 6, pin number 7. And pin number 8. That's all. So you have to connect them to the common ground. So this is pin number 6. Remember that pin number 6 is not interconnected with pin number 5. Hello, Jackie. Ruben, you are far. Let me repeat. Pin number 5, Angelina, hey, Paul. Angelina, Paul. Pin number 5 is not connected with pin number 6. Remember that. If you do a mistake and connect pin number 5 with pin number 6, you are going to damage the Ht12E encoder. Remember that in engineering, safety is above all. So pin number 6 is connected with pin number 7 by using external jumper, male-to-male jumper. Pin number 7 is connected with pin number 7 by using pin number 8 by using external jumper. And then all of these 3 pins will be connected to the common ground by using external jumper. Then you have finished the first step. What is difficulty there? You know, instruction is more important even just rather than doing. Because you just follow instructions. Once you have instructions, you just follow them. Just follow them. In case that they fail to actually to give you what you're expecting, then you can challenge. You know, one of the challenges that you might be facing, you dislike weights. It means you don't concentrate on the message carried by the weights. You concentrate that these are the words. The issue is not the words. The issue is the message. Then the 5th step, Matatu, or the 5th step, read it. Connect binary data inputs. And read it. The 5th step, all of you. Read it loudly, I don't hear you. So you'll take a male-to-male jumper, hello, because you're going to build these circuits on the breadboard, hello, Namvua. So suppose that this is our first input. So you'll be using the male-to-male jumper, and this is another testing point, you have to remember that. Remember that for this side, we don't have any testing point. We just have to check the continuity. That's all. Then we say that, so you'll take a male-to-male jumper, and then so you take that one and connect it with pin number 10, which is AD8. Are we together? Are we together? You take against the male-to-male jumper, and you may connect. You have to remember this configuration because when you be decoding the information, you have to remember where did we connect our inputs. So for this case, we have connected our input AD8 and AD11. Means pin number what? Pin number what? Number 10 and pin number what? A13. So you have to remember. If you fail to remember this pin configuration and you reverse in case of the decoder part, you will not succeed to get the decoded information. Zuena Masebo, read the 6th step. What the 6th step, we are done for that. First step, right? Brighton, is it okay? The next step. Read the next step. Johanna, read the next step. The next step, the sixth one. Number 6, yeah? Read it quickly. Pull up the transmission enable pin. Pin number what? So how can we pull it down? Simple. You take the male-to-male jumper, and then you connect it with a common ground. You have to remember that. Then the next step number 7, read the step number 7. Just read important information. That Ht12E encoder has built-in oscillator, it's not important. Just read that connect a resistor of resistance 680 kilo ohm between pin number oscillator pin 1 and oscillator pin 2. That's all. You try even to build the sentence. You just read as how it has been written. The first sentence is just to give you the overview that this Ht12E encoder integrated circuits, it has a built-in oscillator. So that built-in oscillator needs an external resistor to trigger it in order to oscillate during the encoding. Do you see? He told me that he understands me less. And then he's executing oscillator. So is the actual. So to design the oscillator is simple because you're oscillating always, right? Okay. So this is the pin. Then we have what? We have to connect external resistor. Then this one, the resistance is 680 kilo ohm. Are we together? That is step number what? Number 7. Do I have any circuit that I'm looking about? No, I don't have it. So for yourself also, you have to take this information seriously. You digest the information several times. You digest it, you digest it, you digest it, until you can just remember the steps and draw it from your brain. Because that's the function, that's the one of the functions of your brain, to keep the informations of electronics engineering and telecommunication engineering. That's one of the functions according to what you are telling us. Are we together? Precious? I have answered that question, but maybe the answer that I provided you didn't catch up. Let me repeat. Precious asking a question. Why should we connect a resistor of resistance 680 kilo ohm between the oscillator pin 1 and the oscillator pin 2? The response for that question, I said, Ht12E encoder, they have a built-in oscillator. Say oscillator. Is oscillator a digital circuit or analog circuit? What the function of the oscillator circuit? What the primary function of oscillator circuit? To generate what? To generate you learned oscillator in practical electronics, semester 1, and I heard that you designed. Dominic! What the function of oscillator, Dominic? This guy said that if Dominic will answer that question, you'll give him some money. What the primary function of the oscillator? To produce your oscillation. So the built-in oscillator of HTE encoder and Ht12D decoder, they need an external resistor for them to oscillate. It's just like in case of microcontroller, and especially that in electronics measurements you use most of you, the PIC microcontroller. The PIC microcontroller cannot work. It has first of all built-in oscillator, but it also needs the external oscillator that we call the external crystal oscillator. In most cases, you use 8 megahertz crystal oscillator, Xen oscillator, or 16 megahertz crystal oscillator. In just some few cases where that the microcontroller we have to connect with 32 megahertz crystal oscillator. So for that case, we don't need a crystal oscillator. They just need a fixed linear resistor. That's all. Precious, is it clear? Is it clear? This pencil belongs to? Okay, I will. Is it clear? So the function of this resistor is to trigger the built-in oscillator to perform the desired task when the Ht12E encoder integrated circuits encoding the binary data. Are we together? And step number 8. Step number 8. Connect the D out to 30. The data pin of 40. A. So this is pin number 17. Well. So for the Ht12, for the 433 megahertz RF transmitter, we say that it has only 3 pins. One pin is called the data pin, and the other pins, the first one is called the VCC or VDD for this case, and the other one is ground. So forget about that because we'll discuss it in workshop 60. In workshop 7, we are going to discuss about this one. So this is called 433 megahertz RF transmitter. So connect the data pins of RF of 433 megahertz RF transmitter with the data pins of 40 Ht12E encoder integrated circuit. So are we done? But remember that in your power supply, we are not done. Why? Because when we connect every point, we find there is a power supply. So we don't have a point to control the power supply to our circuit. Zuwena, 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 Zuwena. Do you know that song? So we don't have a point where we have a mandate to control our power supply. So for that case, I forgot here to have on-off switch. And all more than 60 students in this class also, they forgot as their teacher has forgotten. This is called the single throw, single throw, single pole, single throw. So you need on-off switch. Say on-off switch. It's just like this one. So we have switch in electronics. They just work like this one. So this is on-off switch. It's not electromechanical switch. It's just on-off switch to control power. Because if you don't have on-off switch, while you are just connecting, the power is flowing. Sometimes you have made a mistake, then you find that you damage the electronics component. And once, remember that this switch is not turned on until you go for the step number 9. Read 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 the step number 9. Cross what? All. Before what? Turning on what? Before you turn on what? So how do we turn on? So if everything is okay, now we can turn on our DC power supply to supply power to different parts. Are we together? Is it clear? Yeah, so if it's clear, for me, I have a responsibility to give you the electronics components. And I told you that we don't have them in our departments, but that's not an excuse. You have to do it because I would like to see that once you graduate your first year, you at least you have enjoyed how you can design a transmitter, an electronic transmitter, and the electronics receiver. That's one of the strategies that I had since I met you. Okay? Yes, so what you are lacking in your department is Ht12E encoder, and also we are lacking 433 megahertz RF transmitter module. And I told you that is because I love you and I would like to see you to be a practical engineers. Then I have bought them for you. So we have a number of them. You will enjoy them. So if you have understood this one, then think that you can start building the circuit. Because nothing new there. Just need a number of jumpers and whatever, and then connect. But also, we still have measurements, some testing points. We had testing point 20, C, we ended to D, isn't it? A, where is another testing point? A, another testing point is this one. So this is another testing point at D out. We have another testing point, we call it testing point E, where that we have to measure two parameters. The first one, we have to measure the output current. And also the second one, we have also to measure the potential difference. So we should have V out, or we should have a DC voltmeter to measure the V out. But again, we have another parameter, Shkuru. One of the students who is happy today is Shkuru. Shkuru is very happy. So once we end the class, we'll ask Shkuru, what the success of your happiness? Because it's better to be happy. Life is simple, just to be happy. Also here, stop writing. At this point, we have another measurement parameter, which is not only voltage. At this point, also, we want to know the input current. So, milliampere. And also, at this point, we need to know what is the input current. Oh, sorry. Not at the ground, sorry. I just wanted to connect it here. So, it is still one testing point, but we measure two parameters, voltage and voltage, and the DC current. Are we together? Are we together? Are we together? Yes. So for that case, let me leave the homework regarding on that. This is homework 6. So homework 6 is simply we say that draw the table. How do you name this one? This is figure what? Figure 1 for this lecture, for this workshop. What the names of this figure, Johan? Overall what? Schematic what? Logic circuit diagram of 40. So now you are responsible to draw the table 40. Table 40. Table 40. Results. And you have to fill it. You have to fill the calculated values and the measured values. Table of resulting. Of 40. Figure 1. So you have the schematic circuit diagram. You have different testing points. Now it's your responsibility to go and draw what is the table of result. But remember that you are drawing the table of result of digital, logical, or digital system. It's not the analog. Let me remind you. Remember, Mugisha? Robert, what's going on with your best friend? You don't know? Can you give him a conzi? On my behalf, give him a conzi. Okay, I said, remember that you are drawing the table of results of the digital system, not analog system. So we expect you to have a table of results which is actually representing the digital information. We didn't ask you to have a table of results of analog system. That is not analog system. That is pure digital system. Bear that in your mind. Are we together? Do you know tables of digital system? I taught you. Refer workshop 1, 2, 3, 4, 5, 6. Means that, yes, I taught you in workshop what? Workshop 2, workshop 3, workshop 4. I taught about the tables that you have in digital electronics. So if that's the case, let me know. Have you understood what I have taught you? Have you understood? Then it's time for me to appreciate you with aid of the students, those who like to appreciate and congratulate. 1, 2, 3. Ongera. Imara for understanding. Wow for coming. This is the end of workshop 60. I would like to invite you in workshop 7, where that we are going to discuss about 433 megahertz RF transmitter, and then we'll discuss about the decoder, and some other workshop will actually discuss about 433 megahertz RF receiver module. So these are the modules. They are very important. You can do a great number of projects with these connections or with this wireless or short distance wireless communication. So stay connected, stay tuned, enjoy the beauty of electronics. You may also do the simulations because you have the simulation software, whether online simulation software, offline simulation software. You are not limited. What just I gave you the foundation. So you should not say that because you don't have enough time to teach you everything. What I taught you is just a foundation. You are not limited to go further. You are not limited to read some other sources. You are not limited to read some other articles. This should not be the end of your learning. One of the challenges that I experience in your class, it means that when we end the discussion, it's end of your learning. And that's actually will give you a number of challenges ahead because we are trying to give you the fundamental skills. So thank you very much. See you in the next workshop.